How did electrical safety lead to modern breakers? Imagine flipping a switch and suddenly losing power in part of your home. It might seem like a simple inconvenience, but it's actually a safety feature working behind the scenes. The story of how electrical safety evolved into the circuit breakers we use today is quite fascinating. It all started with the need to protect homes and devices from damage caused by overloads and short circuits. Back in the early days of electricity, fuses were the go-to solution. These were simple devices with a wire inside that melted when too much current flowed through, breaking the circuit. But fuses had a big problem. Once they blew, you had to replace them, which was not very convenient and could be unsafe if not handled properly. As electricity became more common in homes and businesses, engineers looked for better ways to protect electrical systems. In the late 1800s, Thomas Edison, who was famous for inventing the light bulb, also patented an early form of circuit breaker. These early breakers could interrupt the flow of electricity and then be reset without needing replacement. This was a huge step forward because it meant fewer interruptions and safer, reusable protection. As electrical systems grew more complex, the need for more advanced safety devices became clear. By the 1920s, engineers like Hugo Stotz developed thermal magnetic breakers. These combined two methods to detect faults. The thermal part responded to prolonged overloads by heating up, while the magnetic part responded instantly to short circuits. This dual system made circuit protection much more reliable. As power networks expanded and voltages increased, breakers had to evolve further. Early breakers used simple air contacts to break the circuit, but these were not enough for high voltages and currents. So, engineers started using oil or pressurized air to extinguish the electrical arcs that formed when breaking large currents. This allowed breakers to handle bigger loads safely. Later in the 20th century, new types of breakers appeared. Residual current circuit breakers, or RCCBs, could detect leakage currents that might cause electric shocks. These added a new level of safety, especially in homes and workplaces. Then came residual current breakers with overcurrent protection, or RCBOs. These combine the features of RCCBs and traditional circuit breakers, protecting against overloads, short circuits, and leakage currents all in one device. Today's circuit breakers are essential for keeping our homes safe. They trip when there's a fault, preventing electrical failures and damage. When a breaker trips, it might seem like a quirky puzzle. Why did the power suddenly go out? But it's really the breaker doing its job to protect everyone. The development of modern circuit breakers was driven by the need for safer, more reliable electrical systems. From simple fuses to sophisticated devices that detect different faults, each step made our homes and workplaces safer. This evolution has helped prevent countless electrical failures and shocks, making our everyday use of electricity much safer and more convenient.